Here's where we do the learning, right? Here's where we do the learning.
No music.
No music. Good idea. Okay, so we are talking today about precision measurement. Who would need to be able to do something silly like this?
Carpenter.
Maybe a carpenter, yeah.
Welder.
Welder.
Any trades.
Yeah, machinists. Plumbers maybe even would have to do some measurement.
Honestly,
I don't know. Plumbers may not need to be that precise, but certainly people that are machinists that build parts. Josh, are you listening? Because I'm doing the teaching part of the day.
but definitely not Carney's.
Definitely not Carney's.
Well,
No.
can we get precision definition at least?
Yeah. Definitely not Carney's. No, if you're planning to go be a Carnival Barker, you're okay.
Are you recording?
I am recording. Thank you.
Okay, good.
So precision is the smallest unit of measurement on the measuring device being used. For example, millimeters on a meter stick. Now I don't have a meter stick, do I? Oh, there is. Yeah, that's right. That one of my kids was messing.
Mr. Bennett, can you give me another precision and answer then later?
What?
One for this dude.
One for this dude. Oh. So the smallest unit of measurement on the measuring device being used. So it might be millimeters. Now this one here, this looks like inches. So this one here has half inch, quarter inch. This one here, the smallest marking is 1/8 of an inch. 1/8 of an inch. So we would say that the precision, there's that can of paint that I was looking for.
Oh.
I knew it was here. 1/8 of an inch, we would say. Now what about a ruler?
Could be millimeters or.
This one here, can you see what's the smallest unit of measure there? No,
Backwards.
backwards. The smallest unit of measurement is millimeter here. Josh, you need to put that away so that you can learn. Okay? Being on Snapchat doesn't help you learn. And then you get behind and you need more work periods. Consider this a period to learn. Millimeters. See, smallest unit is millimeters. Okay. So that's called the precision. Accuracy is how close a measured value is to the actual value. Kind of like, you guys ever watch Price is Right?
Yeah.
You know, where Drew Carey now used to be Bob Barker in our day, right?
Yes.
That was always the best part of being sick, right? You could stay home and watch Price is Right.
And win stuff,
Yeah.
even though,
Yeah.
other people want it.
So how close the measured value is to the actual value. Now, are we ever going to know, like if I'm measuring the width of this table, am I ever going to know the actual width? No, I'm not. Okay, let's just cover up part of this here, because I see what you guys are doing. You're just writing and not learning.
Whoa.
Just chikai, whoa.
What you doing there, Mr. Bennett?
I'm covering it up so you can't write anymore. Accuracy is how close a measured value is to the actual value. So are we ever going to, this is the key idea behind this whole thing. Are we ever going to know if Kelsey's going to put her phone down? And the answer is yes, we do know that because she needs to. Are we ever going to know the exact value of this? No. Anything we use to measure it is just going to be like an estimate. Now, we can get really, 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 really close, but we're never going to know the exact value. There's always a little bit of error, a little bit of uncertainty, you might say. Things that could affect the accuracy of a device. Maybe it's not manufactured properly. Maybe the person building it doesn't know what an inch is, or a millimeter, or they've got a bad sort of, there's probably in the meter stick factory, they probably got something that checks to see are they a meter long, right? Did you know that at one point in time there was actually like a piece of metal with 2 marks on it in a vault in France, and that is the meter. That is the world definition for a meter. Okay? It's no longer the case. They used a scientific way to come up with it. So maybe it's not manufactured properly. Other things, maybe it's dented or bent or damaged. Sometimes the temperature might affect it, right? Things get warm, it expands, and it's cold, it contracts, right? So that could affect the accuracy. Maybe the device has leftover pieces in it from the previous measure, like a measuring cup, right? Like when you measure out milk in the bake shop, right, Josh?
Yeah.
Do you rinse it out and dry out the measuring cup every time?
This person, because she's good at it.
Oh,
Oh, well,
you're a good measurer?
You're always at the bake shop.
Just stealing cookies.
You know things.
no. but-
Okay, so like there might be leftover small bits left in the cup, right? That might affect the accuracy as well. Is that too fast? Oh, now we're going to compare accuracy and precision.
Draw that too?
Is that on your thing?
Yeah.
I don't think so. I think that's just like a fancy picture.
Accuracy, precision, diagram.
That's just a fancy picture. Don't do that.
Okay.
Okay, so like, what's the problem? If this is a target, like we're target shooting, like shooting arrows, right? You guys still do the bow and arrow stuff in phys ed?
Yes,
Lane, are you listening? Because it looks like you're on your phone.
super fun.
Really?
I love hitting my arm because I have weird shaped arms and just.
Is that sarcasm?
Okay.
It's boring, man.
So is it?
Yeah.
So this person isn't very good, right? Like it's all over the place. What would you say about this person?
You're accurate.
He's accurate or he's precise?
Because it's like it's all in one.
This is precise. This is all in one, but just not in the center.
Yeah.
Would you say that, like, if you were shooting a gun, would you say that the sights maybe aren't quite right? Maybe, right? Like, there's no sight on a bow, right? But there's a sight on a,
Looks like you could hit the target, just that, you know.
yeah. He's always in the same spot, just not where he's supposed to be. He or she, because it's not really gender.
Only you.
Okay, so now do you guys have a picture there?
No.
No,
Oh,
I'm trying.
yeah, let's draw.
Oh God.
Well, just do a circle. Like, just do this. You don't need to draw the whole thing. Just go like this.
Do like two little circles.
Just do a circle, and then go like that.
That's an ugly circle.
Thank you. Thank you. Just do that. So that is both accurate and precise, because they're all together, and they're all where they're supposed to be. Right?
Is there 4 dots beside this today?
There's 4, yeah.
No, there's only
Yeah,
3.
so.
Okay, so that one is accurate, and maybe we should, just to be clear, let's do accurate and precise. Okay? Okay, Josh, you're still snapping instead of learning. You are. This one is not accurate, but it's precise. Okay? The person is very good at hitting that one spot, but it's not where they're supposed to be. It's kind of like what you guys do in class. You're very good at being on your phones. You're just not supposed to be doing that.
Yeah, see.
Right? It's not precise. It's trending towards the middle, but not so good.
I don't know
Yes.
my life.
Upward trend, but still under construction. Justice
Use the little one.
needs a little work. Well, isn't that everyone?
Yep.
Hey,
That's what it's all
here, I
about.
want to give you guys some good advice. What do you think? Not accurate, not precise. What's that gonna look like?
Oh, it's just gonna be crazy. They're not
Like
even
just-
gonna be on the map.
All over the place.
That's a better representation. Holy man.
Yeah.
Jesus.
Actually, I would say I would say it might be better to be like, yeah, there, right? Like
Yeah, like crazy.
all over. Yeah, this is almost a little bit precise. Right? Yeah.
Are you going to watch that Elton John movie?
Yeah,
What is it?
The rocket man?
yeah, probably, yeah.
Very good.
Yeah.
How we go?
Uncertainty. The uncertainty is the margin of error. Big words. What is a margin? Like a range.
Margaret?
Not margarine you put on your toast, right? No. The margin. Now you got me saying it. The margin of error. Like Trump can't say the word orange or orange and oranges. Now I can't say it. The margin of error of a measurement. It's how much it could be out by. How much it could be out by is the margin of error. Put your phone down, Lane. We'll start taking phones away, you guys.
Do it, Mr. Bennett.
I am. And you know what? Exam day, there's no phones.
No,
No phones.
no phones.
We should practice no phones. No. The margin of error of a measurement, if not stated otherwise, is half the precision of the measuring device used. Half the precision of the measuring device used. So I'll explain what that means right away.
Are we going through this whole portfolio on one day?
No. So, in other words, if the stick here, okay, that's a hard one. If a ruler has a millimeter as the smallest unit of measure, what is, that's a terrible ruler. Millimeter, what's half the precision? Half a millimeter. Right? If the precision is a millimeter, if that's the smallest unit of measure is a millimeter, then it's half that. What if it's an eighth of an inch? Tough one. What if the precision is an eighth of an inch? No. You're going the wrong way, Josh. A quarter of it, or sorry, a half of an eighth. What's a half of an eighth? A 16th.
16.
Right? 1/16. 2/16 is 1/8.
316.
So it would be half of 1/8. I'm pretty sure they won't ask you on the exam an imperial one on test. But I might on test. Right?
Oh,
What you doing, man? Playing games. Come on. Stay with me. Gotta learn. Gotta learn. Well, that's all I got on that page. Okay. Was that a lot of writing for you guys? No? Precision is related to exactness, but it is determined by the
I read
limit.
the word before, but cool.
Okay. Where? Oh, you never heard that word before?
No.
Gotcha. Sorry, I misunderstood. Precision is related to exactness, but it is determined by the limitations.
I heard of exactly, but not exactly.
Exactness is the how close it is to the correct value, right? Precision is related to exactness, but it is determined by the limitation of the measuring device. That is big words. I think we need to cut that down. So in other words, your measuring device tells you how precise you can be, right? Like if you have a measuring device that only measures, like your odometer on your car. You guys know what the odometer is?
Yeah.
Like tells you how far you've gone, right?
Yeah.
What is its smallest unit of measure? Everyone's odometer is in kilometers, but what does your odometer show?
Wow.
No, it should show kilometers in Canada. Lane, are you listening or playing on your phone? It looks like you're playing on your phone. Doesn't there like a little wheel, like a little white one, that sort of goes like 1/10 of a kilometer?
Oh, that's fine.
Right? So your odometer on your car is 1/10 of a kilometer, right? So like if you were trying to figure out how wide your driveway is and use your car to measure, is that going to work? Right?
What's that, man?
Me driving my car.
T-Rex.
Yes, I'm a T-Rex with my teeny tiny hands, and I can't drive a car. Right? That's what you got out of that little demonstration. The car is limited to 1/10 of a kilometer, right? So you don't use it for measuring small things. You might use it to measure like how far it is to Gilbert Plains.
requires GB.
So it's determined by the limitation of your measuring instrument. If your measuring device is marked off in centimeters, that's as precise as you can measure. Your answer will be to the nearest centimeter. A measurement made with a ruler marked in millimeters would be more precise than a measurement made with a ruler marked in centimeters, right? You are limited to how good your ruler is. I am your ruler. I command you, put away the phones.
So you're gonna own that apartment?
No, I'm just renting. Because of the limited precision of a measuring device, there is always some uncertainty when taking measurements.
Is it by the school?
No.
Oh, that sucks.
Yeah. For example, if you're measuring a box with a ruler marked in centimeters that's slightly less than 6 centimeters, you have to say it is 6 centimeters long. I mean, I guess you could say it's a little less than 6, right? But by rule, you have to say it's 6. You can't make up marks on your ruler. Does that make sense? That's what I'm trying to say. You can't make up marks on your ruler.
You can't just look at it and be like, I think that's.
Well, if it looks like 5.7, you can't, because there's no 0.6, there's no 0.7, there's no 0.8, there's no 0.9. There's just 5, and there's 6. So you round to the nearest one. You cannot give a more precise measure than this because of the units of the measurements. You are limited to the units of the measurements. Okay, everybody with me?
Yes, sir.
Okay? I realize this is not exciting. Trying to make it as entertaining as I can. No, I understand.
So wait, what's this unit about?
Precision measurement.
Okay. So we're talking about
I thought it was about T-Rex there, Mr. Bennett. It's often necessary to record how much uncertainty exists in a measurement. Unless stated otherwise, uncertainty is given as half of the precision of the measuring device. Half of the precision of the measuring device. That's right at the bottom. You got to fill that in.
With Mr. Ben?
Okay, take it.
Who is it?
Someone from Winnipeg might be from my school.
All right.
And we play school.
If it's a telemarketer, say I'm in class.
I would love to buy your product, but I don't care. So just buy. What?
Unless stated otherwise, uncertainty is given as half of the precision of the measuring device. Remember, the precision writing is the smallest unit on the measuring
Oh, I
device.
thought you were talking about the precision of the, in Brandon.
Precision auto.
Yeah.
No. No. For example, the box example given above, I think this is probably on the next page. For example, the box given above. Telemarketer.
Oh, yeah. I thought it was about this morning.
Yeah, sorry, man. The box example given above, the length would be 6 centimeters with a precision of 1, because that's the smallest unit is the centimeter, and an uncertainty of 0.5. Where does this 0.5 come from? Lane, where does the uncertainty of 0.5 come from?
I don't know.
You don't know?
Wait,
Because that's
half of one.
half of 1 centimeter, which is 0.5 centimeters. Okay? So it's actually fairly easy as long as you kind of know what's going on. It's not that hard. Okay, Josh? The smallest unit, I'm just going to keep repeating myself like I'm teaching junior high. The smallest unit of precision, the smallest unit on the measuring stick is the precision, and the uncertainty is half of that. And you can all multiply by 0.5. Exactly. That sounded like a cheer.
Sorry.
It wasn't a cheer? Why would you be sorry about cheering about it?
So 1 centimeter? Can you come back over?
1/2 times 1 centimeter. Okay, so how is it written, Mr. Bennett? This is how it's written. The measured value, you guys may have seen this on things. Measured value plus, and then this is, you say this plus or minus. It's a plus sign with a minus sign below it. If you look on like electronic devices, sometimes they show like plus or minus the voltage or something like that. Okay? Anything that is measured precisely has to have an uncertainty. So it's the measured value plus or minus the measurement uncertainty. And this will make more sense when I give you an example. So how would I write that the box is 6 centimeters with an uncertainty of 0.5? How would I write that in this format? You would write the box, length of the box would be 6 centimeters plus or minus 0.5 centimeters. I like it like this, all in one line. 6 centimeters plus or minus 0.5. So that means, right, it could be anywhere between 5.5 and 6.5. So how do you get the 5.5 and the 6.5? Well, 6 minus 0.5 would be 5.5, right? 6 minus 0.5 is 5.5. And 6 plus 0.5 would be 6.5. That's how, that is called the range, or the tolerance is the correct word, I believe. Am I right, Mr. Kozlowski? It's been years since I taught this. It's called the tolerance. And shouldn't we all be a little more tolerant these days?
I think we are getting there.
We're getting there. We're getting there. So 6 plus or minus 0.5, right? Okay. That's all I got. Let's do some examples, right, Kelsey? We're not going to get to the practice today, are we? No, that's okay. That's okay. Maybe we'll get more attendance tomorrow. So I want you to state the precision and uncertainty in the following measurements. State the precision and uncertainty in the following measurements. An odometer, which is on a car. An odometer odometer records. That's a stupid word, because you can pronounce it as records or records, and it means two different things, doesn't it? And then there's words that sound exactly the same, like to, that are spelled 3 different ways. What a stupid language we speak. The days of the week, I believe they're named after Greek gods, I think, or something. Maybe that's other months, I don't know. I'm not sure. I know a lot of stupid things, but I don't know that stupid thing.
Mr. Bennett, why are they like kind of numbered
They're all weird, yeah. Yeah, they're weird. An odometer records distance traveled to the nearest kilometer. So what is the precision? Let's just write the letter P. The precision, if it's to the nearest kilometer, the precision would be 1 kilometer, because that's the smallest unit on the odometer. And the uncertainty, which we'll just use a U, would be 0.5 kilometers. How'd you get that, Kelsey?
times it by
1 times 0.5. Exactly. 1 times 0.5. So that's pretty easy. The outside temperature was recorded as 12 degrees Celsius. It's warmer than that today. What is the precision? I would say 1 degree Celsius. That's the precision. And the uncertainty would be 0.5 degrees Celsius.
is it always just going to be
It's always half. But is it always going to be 1?
yeah?
No. And Mr. Kuz's just telling me a break. It's not all, the answer's not always going to be 1, because there are some, like in measuring cups, right? Sometimes they're shown, like Josh, like in like increments of 50 milliliters, right? Like there's a little line, there's 0, 50, 70, oh no, 0, 50, 100, 150, 200, right?
Yeah.
So you would say the precision there would be 50, and the uncertainty would be 25. So it's often the number 1, but not always. Harpreet says it took him about 5 hours to drive from Vancouver to Kamloops, BC. Remind me to tell you a story about that. because that's what you come for, is the stories, right? So the precision is 1 hour, and the uncertainty would be half an hour. Because apparently Harpreet's watch only measures to the nearest hour. So when we were in Whistler with the band,
That's like.
Yeah. yeah, I mean,
But you want
maybe there's a rule on the exam that I'm not aware of, but I would, it's probably better, Kelsey, to always have the same unit. Like if this is hours, that should be an hour. Right? Yeah. Probably best, but yeah, you'd probably get away with it. Genevieve is mixing juice in a jug marked in quarter liters.
They start Wednesday, right?
Yeah. Quarter liters. She measures the amount of juice in the jug to be 2.5 liters. Write the measurement of the juice in the jug in the form measured value plus or minus measurement uncertainty. Okay, so let's just, what is the precision here? The precision is 1/4 of a liter, which would be 0.25 liters, right? That's the precision. 0.25. Which means the uncertainty would be half of that, 0.5 times 0.25, or 0.125 liters, right? You're taking 0.25. Well, 0.25 is like 0.250, right? 0.5 times 0.250, 0.125 is the uncertainty. So we would write the measured value as 2.5 plus or minus 0.125. And then usually put the unit at the end. Am I right, Ms. Kozlowski? Put the unit after the plus or minus? You know? In your experience? That's what I remember.
Do you remember
Like,
that?
well, I mean, you probably wouldn't get marked wrong if you put liters and liters, but I think you're allowed to just put liters after the answer. I could be wrong. So it's 2.5 is the measurement. How much could you be out by? Plus or minus 0.125. How does that sound?
One more question. B, what is the range of volume?
Oh.
That would be in the measure.
Oh, so the range of volume in liters that could be in the measurement. Can I just do it all in here?
Sure.
So that I'm all talking. So what is the range? So the range is, so you subtract. So you go 2.5 minus 1.25, which would be 2.375, right? So you do the subtraction, 2.5 minus the 0.125, and you also do the addition, 2.5 plus 0.125. So the range is, that would be 2.625, right? So we would say, oh, there it is there. We would say the range is 2.375 to 2.625. The actual, not centimeters, liters. We would say that the actual volume is somewhere between 2.375 and 2.625. You next? Yeah. Gilbert.
Which one, Mr. Bennett?
Yeah.
Hopefully I'll probably hit you with something, but I'm scared too. I don't care if I get suspended because there's only 3 weeks of school left, so.
Actually?
Yeah, and I'm gonna punch you in the head pretty soon, so if you can do that again. You come at me then! Oh! Touch me. Touch me. Touch me. I just come out like that. I'll punch you though, not like hit you in the head.
Yeah, I ain't Genevieve.
Excuse me, don't bring me to this. Don't bring it. I'm not that person. No, I don't get mad. Like,
No one's a
I don't stomp out the like the girls. Not you though.
No,
You have a reason to get mad though, but I don't. But I just want to punch you.
No one doesn't go.
I don't do that because I'm a cool kid and kids don't do that. So. Look. I didn't notice I had the other Kristen Castle shirt on. You guys didn't notice I changed it. Oh, you did? I was wearing the other Kristen Castle shirt. It was orange, but I'm wearing a red one now. So. Oh, he's recording something. Is he recording our class? He's recording. Yeah, it says right here, it says recording. He's recording some of this. He's recording me. And this whole time I was like, yo, good. And I was giving the things I was like this.
Is it still on? Oh, it's still on.
Was it playing this thing?
You could probably hear us talking on there.
Oh, you're stupid. You gotta press this.
Hot as balls in here.
Why is it to wash your class though? That's the thing. How do you... I got iPhone. My iPhone's out right now. My iPhone's chilling. Are you videotaping us?
Am I videotaping
Yeah.
you, no?
You are.
No, I wasn't.
Yeah, you are.